Okay, so we're now recording. Yes. What's up, Dennis?
Hi, how you doing?
Hey, I'm okay. Well, real quick background. Cupertino, I don't think there's any other big corporation or job that you'd have other than Apple.
Right, yeah, any young guy living in Cupertino, there's really only one reason he would do it. It's because he either works at Apple or he used to work at Apple.
Yeah, so we were both ex-Apple workers there. I was a contractor for about a year. So I was at Bub Road doing Ruby and touching up on all kinds of technologies there.
Okay.
Yeah, with the pandemic, I am a little rusty, okay? I've been moving and stuff, and so I'm not sure if the programming exercises are going to be
That's all right.
So but I'll definitely try to hang.
No pressure.
Yeah. Dennis, what about you, man?
As I was just saying earlier, I'm glad you've started this off and took the initiative on this because the past couple of weeks I wasn't really able to work on Berlin. Even though I released it only, I think, a few weeks ago. So I'm glad we're doing this because this is bringing my focus back to Berlin.
Understandable. It's weird times right now. I think in the air, everybody's kind of just wondering what's next, so.
For sure.
Yeah. I guess what were you doing at Apple on Results Way?
I'm afraid I can't really talk about it.
Oh, nice. That
I have to give the standard answer.
Right there, right? This is actually came from Apple there. From the.
That's right. Yeah, that's the correct emoji. Yeah. I mean, I can talk about the technologies I used and that kind of stuff, how long I was there for. I was there for 4 years, pretty much on the dot. Worked a lot with JavaScript for the most part, a little bit of Clojure and ClojureScript here and there.
Okay.
And I think initially sporadically some Ruby. I used to do a lot more Ruby before Apple.
Okay.
But yeah, my time at Apple was JavaScript for a large part and then Clojure toward the end.
Nice. Did you use a framework or?
Yeah, so I worked a lot with Angular 2 at the time. Now there's up to 10 or something.
It's too fast, man. Yeah.
And yeah, I worked with also just plain JavaScript, and then later on a little bit with ClojureScript and Clojure, like I said.
Were there frustrations in those things that you touched on that led you to this new thing called Berlin?
So one of the things I learned there was Clojure. I started learning Clojure when I was there. And I definitely felt that it was a steep learning curve coming from JavaScript going to Clojure, because not only are you learning a new language and a new syntax, but you're learning also at the same time all these new concepts. And
yes.
So if you learn all these new concepts at the same time, that can be a bit difficult because sometimes, is this a syntax quirk or is this the new concept I'm learning right now? So
yeah.
that can be a bit challenging. So, and at the same time, especially toward the later years of doing JavaScript, I've become a bit not annoyed with JavaScript, but I definitely noticed inconsistencies in the language, things that could be simpler, that kind of thing. Definitely room for improvement there. Berlin itself initially just grew out of curiosity. I was just curious, what it would take to build a transpiler. And then over time I was like, maybe I could actually turn this into something that I would use myself. And so that's kind of the thing where I came from is, can I build something that makes JavaScript simpler and makes programmers happier, hopefully, when they write something like JavaScript? I think for JavaScript developers, Berlin syntax will look very familiar, but the idioms are all very Clojure-esque. So Berlin draws huge inspiration from Clojure. So any function from the core language of Berlin that you see probably exists by the same name in Berlin.
Okay.
the function signatures are probably all the same, not the implementations. Those are all implemented from scratch. So the performance characteristics may differ, but the signatures are probably all the same. So basically, if you then wanted to go from JavaScript to Berlin and then optionally from Berlin to Clojure, I think Berlin should make that transition a lot smoother. Now, that being said, Berlin is not only for those who want to eventually learn Clojure. I think Berlin has a lot of value to offer on its own. Hopefully, it just makes for a better development experience. But I should preface all this by saying that Berlin is in very, very early stages. Like I said, I only released it a few weeks ago. So this is alpha, pre-alpha.
Before I left, we were hanging out and you gave me a quick sneak peek of Berlin. And it was enough to get me excited and,
Cool.
for us to talk about this, because the syntax, from what I saw, is promising. So you mentioned Berlin draws from Clojure, some of the signatures, programmer happiness.
Well, I know programmer happiness is kind of the Ruby thing. I don't know if there's as much of a focus on it as in Berlin as in Ruby.
Okay.
But I do think that somebody who programs Berlin, hopefully, once it gets to a stable and kind of battle tested stage, that it would be that whoever writes Berlin is going to be happier than writing JavaScript.
Yeah, so speaking of Ruby, which is an object-oriented programming language, we have a paradigm there that looks at everything as an object, versus Clojure. I'm not sure if that's a functional programming language.
It is.
Okay. So yeah, why not OOP?
Well, so I used to be a fan of object-oriented programming. I used to work a lot with Ruby. I thought Ruby was the coolest thing when I worked with Ruby. I don't know if necessarily for its object-oriented properties, but probably more so for the programmer happiness centricity that they had that focus. And I thought the syntax was pretty. I don't know if I still feel the same way, but definitely at the time, I'm not saying it's ugly. It definitely has its.
Now compared to Berlin, yes, everything is ugly now.
No, I'm not saying that. I think I would still like working with Ruby. I think Ruby is a fine language. When it comes to object orientation in general, I take very much and I first learned this from colleagues at Apple, but I also learned there's some great videos by a guy named Brian Will on YouTube. He has a good channel where he did a few videos on why object-oriented programming is bad. And I take very much a Brian Will kind of stance on this issue of object-oriented programming. I really don't see any merits to it. I don't find a reason anymore to use it. So the way Brian Will lays it out is that object-oriented programming was initially a solution to a problem of data management. So if you say, you have two options pretty much. You can either say we're going to write programs functionally, or you could say we're going to write programs imperatively. If you do it functionally, that means you don't want to mutate any data, or as little as possible. If you write them imperatively, it means you do want to mutate data. But then you run into all kinds of issues when it comes to consistency, when it comes to multi-threaded environments. How do you know that the data hasn't changed from under you, that somebody else was messing with it as you're consuming it, that kind of thing. And Clojure's answer to this problem is basically just don't mutate if you can help it. Then you don't ever have to worry about these things. Just get used to the fact that your data might be outdated. And if you absolutely have to mutate, do so in a safe way. And they provide the requisite data structures for this type of safe mutation. The object-oriented approach is encapsulation. The object-oriented answer to the problem of data management in a world where data might change from under you at any given moment is data encapsulation. But it doesn't really solve the problem. There is still no guarantee that no matter how many steps along the way or how many chains apart the data you're looking at is from its parent or something, that something still hasn't changed from under you. That still could happen. And as Brian Will points out, there's also all kinds of philosophical issues you run into, but not philosophical of the interesting, good kind, philosophical of the kind, kind of pointless, navel-gazy questions you have to ask yourself, like, I think he gives this example of, if I have a message class and I want to send a message, do I put a send method on the message class, or do I have a separate sender class that takes a message object and sends it? Or do I have a recipient class that receives a message? You have all these kind of pointless questions you have to ask yourself in your data modeling that just take a lot of time. And at the end of the day, they don't really make a ton of difference.
So just by having a function that always takes arguments.
Right. Just have a function that takes a message and sends it. Like, what's the big deal? If you need inheritance, just have a map and clone it or merge it, or, all these things you can do easily without having these additional layers of abstraction. You don't need those.
Interesting. Yeah, and you also deal with different developers that all have their thoughts on how they implement object-orientedness.
Sure.
And it's kind of hard on the brain, especially when you're seeing thousands of code lines. So, cool. Okay, cool. Is there a way to maybe organize Berlin code? I know that Rails is huge when they did
convention over configuration.
Yeah,
that kind of thing. Mm-hmm.
They came out with their MVC architecture, and it was kind of a revolution at the point. Everybody was so relieved to see someone had an opinion on where to put all of this code that used to be all bundled together. It was just spaghetti code all in one file, in a PHP file, whatnot.
Sure.
And then now we're kind of back in that chaos, except a little more structured, I guess, with React. Though it's a framework, they actually just give you the pieces, and it's up to each team to sort things out. So, I don't know, does Berlin have any kind of...
Well, I think to go back to Rails for a little bit, I do see a huge advantage of that approach, convention over configuration. I think it was called, right? That's what they called it. I definitely see the appeal, and it makes sense. Like, if I open another team's project, I already know where to look because we all follow the same conventions. That's a huge upside. Yeah. I think a lot of developers don't like it because they would have to learn the conventions first. They can't just jump into programming. And so there's initially some learning curve, but I think that's a bad reason not to do it. The only reason I think you should ever ignore the conventions if for some reason you've decided that the conventions are bad. If you think you've refuted them and you have a better approach, yes, I think that's a good reason. But otherwise, I think the convention over configuration approach is very sound. And I agree. I'm hearing a little bit between the lines that you might not be the biggest fan of React because they don't have such conventions. They just give you a toolbox, and then it's up to you how to put the tools together.
Yes.
I think React is a disaster. I've worked on, the technology is sort of okay. I've worked on several projects that use React, and it was always a mess because they don't have any conventions.
Yeah.
Or if they do, it's only them that have those conventions, So there's very little overlap. All that being said, I don't necessarily think it makes sense to compare Berlin, a language, with a framework like Ruby on Rails or a framework like React. Because
that's a great point, because there might be somebody watching going, "Oh yeah, here we go, another JS framework? Really? Like, does the world really need another JS framework that everybody's up to their necks?"
Right. I think seeing what's out there in terms of JS frameworks, actually the answer is yes, the world does need another JS framework, but a better one. But no, Berlin is not a JS framework. It's just a language. So it's not limited to front-end development or any of that. And it's not a framework. Berlin itself doesn't have any conventions, just like Ruby itself doesn't have any conventions, but Rails does. And you could certainly build a framework in Berlin. There's nothing stopping you from doing that. But Berlin itself is just a language.
Okay. Cool.
Yeah, that's all there is to it.
Okay. All right. But yeah, so in terms of organizing, let's say I'm a team and I saw the syntax and I said, okay, I'm sold. Mm-hmm. Should we just implement MVC or something similar, or do you have a new thought on where code should live or be organized?
If you want to build a web server, sure. I think MVC works fine. Yeah, you could build a web server in Berlin, and then I think MVC would be a good way to do that.
Cool. All right. Cool. So, yeah, I was curious how Berlin came about, and you touched on it, which is it started from curiosity, mm-hmm. And then it's something you actually wanted to use yourself. My God, right. What? That's the problem with these big frameworks that that giant tech companies back, mm-hmm. is that they're backing these things, but they're not actually using it. They say they use it, but it's actually.
Well, I can certainly tell you that if you build something that you yourself have a stake in, because you're also the consumer, the product is always going to be better.
Absolutely.
Because you see the pain points as you use them, you recognize the problems. Yeah, definitely.
Yeah, practice what you preach, right?
Yep. Yeah.
Cool. Was there a certain type of programmer you had in mind? Can beginners dab into this, or this is more for intermediate?
I think anybody could just jump right in. Probably Berlin is a simpler language to learn than JavaScript. A lot of people start with JavaScript, but given the inconsistencies and the confusions that JavaScript can harbor, I think something like Berlin might honestly be easier because it's a simpler language. There's fewer concepts to learn.
Okay.
So a beginner would hopefully have a good time. That said, I haven't thrown this at any beginners, so maybe the test of time will tell us differently, but I think so. I think it would be good for beginners, but I think it would also, developers who've been developing for a while, I think they might appreciate this too, because it's simpler and because it's more consistent. So hopefully they would, like I said earlier, if a seasoned JavaScript developer who's very familiar with the quirks of JavaScript and would rather do without them, hopefully would enjoy Berlin because it doesn't have those quirks.
Cool. And because it's a language and not necessarily a framework, it doesn't matter the type of coder. So it can be a web developer or even an API guy, or even some Arduino robotics person. Who knows?
For sure. You could write anything at all you want. I mean, basically the way it works is Berlin is a transpiled language and it transpiles into JavaScript. So the only condition is that you run in some JavaScript environment. So that could be a browser. So you can use Berlin for front-end development if you like.
Wow, awesome.
You can use it to write a web server, like I said earlier, if you run it in Node. You could, I don't know, if there's machines that run JavaScript, you can run it, you can use it.
Nice.
Yep.
I was a little confused at first because I'm going, wait, so then Berlin is not a framework of JavaScript. It's another language, yet there's JavaScript underneath, and if there's a JavaScript engine, you can run Berlin. That makes things a little confusing, but this is actually another programming language, but that it can transpile using a JavaScript engine.
Yes, that's right. So I think a more apt comparison would be comparing Berlin to CoffeeScript or TypeScript or something like that.
Okay.
Because those are also just languages. They don't have they're not frameworks. They don't tell you how to write your code or where to put things. They're just the lingo.
Okay.
And yes, you also just pointed out something important. Not only does Berlin transpile into JavaScript, the transpiler itself is written in JavaScript and runs on Node. Yeah, so you need to have npm you need to have Node installed, and then you can install Berlin using npm.
And you're going to do all this maybe in a few minutes.
Yep.
Right?
Yeah, I'm happy to code live. Absolutely.
Okay, cool. Real quick, Transpiled, for those that didn't take their CS courses or was falling
neither did
asleep,
I.
there's compiled, there's real time interpreted, and then now there's transpiled.
Right.
I'm not sure if transpiled is the latest thing, but yeah, if you can.
Oh yeah, no, it's not the latest thing. They're all just different. I mean, okay. I've never taken a CS class either, so take this with a grain of salt. But my understanding is compiled just means you have a program that takes some string of source code and turns it into machine code.
Okay.
And then the machine runs that machine code. Whereas interpreted just means you have a program that reads the source string, but then executes it directly and freely without turning it into machine code.
Which takes longer, and it's kind of the criticism of a lot of programming languages for performance.
Right. Yeah. I'm not too familiar with that. I've heard that too. I'm not too familiar with the performance characteristics and comparisons between compilation and interpretation. Okay. But I know, for example, that Ruby, MRI at least, is an interpreted language. Or MRI is the interpreter that Mats wrote to interpret Ruby. In C, I believe. I think that interpreter is written in C. But there's also a Java implementation of that interpreter. With
JRuby, which is compiled, which then that's why big enterprise companies like, because it's faster, it's compiled, you don't have to always
is it compiled? Okay.
Runtime every line of code, all the in the moment. And so it saves
right.
CPU
right.
power.
And then when it comes to performance characteristics, I'm aware of something called just-in-time compilation.
Yes,
where you say you don't compile everything.
Which
and
is
And I believe, so this is the approach where you don't compile everything at the beginning. You compile the things that you need at the time that you need them. I believe. I've never written any program like that, but I believe that actually JavaScript that runs in Chrome works like that, if I'm not mistaken.
Okay.
But all that said, Berlin is neither of that. It's neither compiled nor interpreted. It comes closer to a compiler because what it does, Berlin is itself, the transpiler itself is a program that takes a string of source code and then spits out, not machine code, but it spits out before runtime, another high-level language. So it's not a low-level language like machine code. It's another high-level language. And in this case, that high-level language happens to be JavaScript. You could certainly write the translator to spit out a different language. You could write Berlin and spit out Ruby code if you wanted to. It hasn't been written yet. But so I think again, with very, very little CS fundamental skills, the never taking a CS lecture, the difference between a compiler and a transpiler is just that the compiler spits out machine code and the transpiler spits out another high-level language.
Okay, very cool. Is there a way to drop out of Berlin and inject a line or two of JavaScript in your Berlin program?
Well, the output of any Berlin transpilation is always going to be JavaScript.
Okay.
So I don't know if there would necessarily be a reason to do that because your end product is going to be JavaScript anyway.
Well, no, because maybe I'm still stuck on jQuery and I like it and I continue to...
Oh, there's nothing stopping you from using jQuery in Berlin.
Nice.
Yeah, so any library that's available in JavaScript, you can use from within Berlin because recall that all that Berlin does, Berlin is never run, right? It's a transpiled language, so it spits out JavaScript, and if that JavaScript loads jQuery and then includes a $, it's just going to do what JavaScript would normally do. It's just going to run that. Yeah,
that's great.
Uh-huh.
That's really it's going to help. I think adapt a lot of people because I think JavaScript is currently the most popular programming language.
I believe so. I would not be surprised. Yeah.
It's coming in at so many different angles here in the technology world.
Mm-hmm.
Cool. All right. The engine underneath Berlin is Node.
Right.
Or in the future, it could be anything that has a JavaScript engine.
Right. I mean, currently the transpiler is available as a node package.
Okay.
But yeah, there's nothing stopping us from putting it on a different package manager in a different ecosystem and using a different language to run the transpiler.
Nice. Why the name Berlin?
Oh, it's just a tip of the hat to my old stomping grounds. I used to live in Berlin, and so I was looking for a name, and this just came to mind. I was also looking for a name that wasn't taken yet.
Oh, nice.
I had some other ideas, but surprisingly, there are surprisingly many programming languages. So, yeah, Berlin worked.
What is that URL again?
Berlinlang.org, I think.
With a dash in between the words.
No dash.
No dash?
Nope.
Okay, one word, berlinlang.org.
Mm-hmm.
Okay, cool. So in terms of performance, because it's a transpiled language, it depends on your computer and the JavaScript engine. So that's cool.
Well, I mean, we can ask about performance in terms of what's the performance of the transpiler itself, and then what's the performance of the JavaScript code that it spits out.
Yeah.
I mean, the transpiler itself, again, this is the first transpiler I've ever written, so I'm sure that it's not sophisticated in any way. I tried last night just for kicks. I tried transpiling a file that had, I think, 13,000 lines of code, and it took about 5 seconds. I don't know if that's super fast or super slow. It strikes me as tolerable. And then as to the JavaScript code itself that it spits out, it should be fine. I mean, there's something to be said about the fact that Berlin, because it's a functional language, none of the functions in the Berlin core mutate any objects. They're always copied instead. So that's usually the first reservation people have about functional programming, is that it seems expensive because instead of mutating objects, you're copying them. And that is certainly true of Berlin. And in the future, so I would imagine from a memory standpoint and possibly from a performance standpoint, Berlin, there's some improvements to be made. That's not to say that it's slow. I would imagine that for the vast majority of just run-of-the-mill applications, Berlin works perfectly fine, both in terms of performance characteristics and memory characteristics. That all said, in the future...
I was thinking because browsers are now implementing multi-threaded JS engines that Berlin fits perfectly for the times right now, because with the functional nature that it's not mutable, it makes it easier to deal with multi-threaded.
For sure.
Yeah. So in terms of performance, actually, it may cost in terms of memory, but you're going to be going parallel now.
Right. Threads. If you ever run Berlin, I'm not too familiar with efforts to turn browsers into multi-threaded environments, but if you ever run the JavaScript that's spit out by Berlin in a multi-threaded environment, you can not only can you do that, but yes, because you never mutate any data, not without going out of your way to do so. You have to do so very conscientiously and carefully in Berlin. It's definitely discouraged, but if you do, then it's kind of on you to do the necessary upkeep and safety precautions. But if you don't go out of your way to mutate data, it should be safe to do so, easy and safe to do so. Definitely, it's inspired by all the mechanisms that, or not all of them, by some of the mechanisms that Clojure uses to make thread programming in multiple threads easier and safer. So that should work hopefully easier in Berlin than JavaScript out of the box. Nice. And also in terms of memory concerns, these are problems that have been solved. Like this initial concern that people raise against functional programming, that it seems expensive because you're not mutating. There's something called a persistent data structure, where you're not copying the entire thing, but you're only copying the thing that you really need. So these problems have been solved. It's just they haven't been implemented in Berlin yet. So let's see if people even use it, and then maybe I'll implement persistent data structures.
Okay.
So that there's less of a concern in terms of memory.
So Berlin is functional based. How do you share functions inside classes if there are even ideas of classes?
There are no classes in Berlin. No, there are only functions.
How do you reuse a function?
Put it in a variable. You put it in a variable and use that variable in multiple places.
You're shattering a lot of object-oriented minds right now.
I mean, if you want to have some collection or some composite data structure that holds multiple functions because you usually use them together or something, there's nothing stopping you from just putting them in a map, if that helps. Right. So the way I like to think of it, if you want to put it in object-oriented terms, to ease the transition into a language that doesn't have any objects, just think of maps, hash maps, as an object whose keys are just properties on that object. And
there's a sense of relief in all of this. It's so simple. It's like all of these different ways of reusing code. And now you're just saying, just use a hash map.
Right. Just use a hash map. There's really no reason to use objects if you can have hash maps. And of course, that's to say that even hash maps under the hood are implemented using functions. So technically, you don't even need hash maps. But once you've implemented hash maps, then yeah. I think it might ease the transition thinking of hash maps as objects. They're not in Berlin, but of course, even in JavaScript.
Yeah, they're objects in JavaScript, right? Even in
JavaScript, objects just utilize hash maps underneath the hood. So, or not even so much underneath the hood. It's very plainly visible when you inspect objects in the console that they're just hash maps. Even arrays are just hash maps with numeric keys.
Oh, very nice. Yeah, cool. Let's see some Berlin.
Can you see this?
Yes.
Ready when you are?
Yeah. Let's see what's on your website and then go through each of the different header sections here and just kind of talk through briefly and then demonstrate in your terminal there what we're seeing.
Sure. Well, so if you pull up this site, you get the entire documentation. So first, if you want to just go over it step by step or like from top to bottom, basically, it starts with just the primitives and the data structures and the literals for both. Maybe actually I should start with, if you want to install Berlin, you just do npm install Berlin. It's actually Berlin lang. Yeah. Or you can just install the Berlin CLI, and you want to do so globally. And after you install this, you can then type the Berlin command, and that's when you get this prompt. You get a Berlin REPL.
Nice.
And so basically Berlin has all these different primitives. So we just have regular strings. Something to note about strings is, unlike JavaScript, Berlin only has one type of string. I think in JavaScript there's 3 different types now. There's double quoted, single quoted, and then there's backtick strings. And the backtick strings allow you to do string interpolation, and they also allow you to have line breaks in the strings. In Berlin, there's only double quoted strings, just like in Clojure. And you can have line breaks in strings, so you don't need to do anything.
What about interpolation?
There's no string interpolation, but there's a stir function in Berlin where you just put foo1 bar, for example.
Okay, so it's a function because everything's a function.
Right. Yep.
Yes. Okay.
String interpolation to me is just fancy syntax it's handy, but it's arbitrary in the sense that presumably the compiler or interpreter or whatever has to apply some special sauce to understand what's going on there. Whereas if you do it this way, it's just a function, so you don't need any extra magic. Then you have numbers, nothing special there. One thing I borrowed from Ruby is you can use these underscores as thousands delimiters because they're easier to read.
I didn't even know that underscore exists in Ruby.
I think so.
I've never seen that. That's pretty cool.
Let me make sure I'm not full of shit, but I think it's true. There's Booleans, nothing fancy there. And also, when it comes to numbers, decimals is also just a number type. There's only one number type. There's no big int or long or all that stuff. There's just numbers. Then there's something new, also borrowed from Clojure. I'm not going to say every time I borrowed something from Clojure because I borrowed a lot from Clojure, so just keep that in mind.
Okay.
But there's something called a symbol that starts with a colon. Symbols are useful for hash maps for dictionaries, but you can also use them as standalone values. And they implement under the hood JavaScript symbols. And then we have
Hold on,
nil.
so pause. This is similar to Ruby symbols because they all lead to basically keys inside a hash, right?
Yeah, actually in Berlin they're called keywords, just like in Clojure, but sometimes I call them symbols because they implement JavaScript symbols, so I get confused myself. And also because in Ruby, yes, the things that start with colons are called symbols in Ruby. Yeah, you can think of them as very similar as symbols in Ruby. I think, if I remember correctly, it's been a long time since I delved into the depths of the Ruby programming language, but I think symbols are actually really part of the core of the Ruby language, right? Because isn't every method stored in a symbol or something? I forget.
Yeah.
They're not that important in Berlin.
Okay.
They're just standalone values that are handy to use as keys in dictionaries. And there's something to be said about, the same symbols or the same keywords. I should call them keywords. The same keyword they're equal to each other.
Wait, whoa, these function arguments. What's going on here? What's a function here? Where are the arguments? Is this some kind of splat array? What the heck is going on?
There's no splatting going on. So basically, this is very simple. I think the only thing that might confuse some people is that this equal sign is not used as an operator. It's literally just a function name. So just like in JavaScript, the function name comes before the parentheses, and then the parentheses mean that you invoke the function. So there just happens to be a function called
Is equal.
Right.
Okay.
So that's all there is to it. Now, in JavaScript, you couldn't write it like that because in JavaScript, the equal sign has a special meaning. It's an operator.
Yes.
But in Berlin, there are no operators. There are only functions. So likewise, with the less than function, you just type it like this. So if you wanted to ask, is 1 less than 2, that's how you would write it. You would just write the less than sign. This is also borrowed from Clojure. So nothing in Berlin is stopping you from using all kinds of special characters in function names and symbols. You can just do that.
This equal sign looks like something that you shouldn't be writing.
Right. I think if you try to override the equal function, funky stuff is going to happen. But even the equal function isn't even part of the transpiler. The transpiler doesn't know about this function. It's actually just part of the Berlin core.
Language.
So Berlin, when you install Berlin, comes with a core library that you can include. It's highly recommended that you do because it has many handy functions that you can use. But equal is one of those, and it isn't even part of the transpiler. So when you start the Berlin console, all of the core methods, all the core functions, I should say, they're loaded and available by default. That is not the case when you just run the transpiler in a file. If you want to use any of the Berlin core. And there's a caveat there because you can use the core without problems in Node. If you run the result of the transpilation, the generated JavaScript, if you run that in Node, you could just use the require function, just like you would in Node. In the browser, that's still something that has to be worked out. So if you want to access any libraries or any import of anything, including the Berlin core, is a problem that hasn't been solved yet in Berlin. This is a common problem in JavaScript, that because there are different JavaScript environments, such as Node and the browser and what have you, they all use different import statements. So I want to find a good way to abstract that away. I just want to have one import statement, and then you don't have to care about where your generated JavaScript runs. I think that would be very nice, but I haven't found the solution for that yet.
That sounds very in line with what I'm seeing with Berlin so far, which is you are taking every facet of a programming language and you're simplifying everything down to the simplest possible thing. And in this case, even how you include dependencies.
Right, dependency management, yeah. Okay, and then there are the null value is called nil. One thing you may notice is if you type nil, actually what it prints here, and this is the same for the keyword and it's the same for the function here, it actually prints the result of executing the JavaScript that this generates. Because in JavaScript there is no nil, there's only null. This may change in the future version of Berlin. So if you type nil and hit return, it might just print nil. But for now, I think it's actually helpful because Berlin is still in such an early stage to see, for debugging purposes, what the JavaScript return value is. And then there's also just undefined directly borrowed from JavaScript itself. So that will be the default value for variables that haven't been initialized, say.
Okay. And also another thing, if you could go back, you notice that there are no commas in between each of the arguments here. That looks really weird at first.
Yeah, so this is another thing borrowed from Clojure syntax and another simplification. And trust me, it looks weird at first, but once you're used to not having to type commas, you will never go back to a language that makes you write commas. You can use commas if you want. You could write this. It doesn't make a difference. It'll just treat the comma as white space. It handles commas just like Clojure does here. But again, they're just discouraged. Just don't use commas. Yeah, and then there's three types of collections. There are arrays. Same thing applies with commas. You don't need them. When it prints them out, you see the commas because it prints out JavaScript.
Nice.
Right. Then there are maps. They start with the tilde and then the commonly used curly braces. Like I said, if you want to use keywords as names or keys, that works fine. So you could have foo1, bar2. Maps are the only thing where I could see commas being useful just as a visual cue where the pairing ends. Okay. But even that you get used to over time. You just do it in your head. You don't need the mental guidance there for commas anymore. So what you see here is that this tilde and curly brace, they implement JavaScript maps. So they implement the map constructor. They don't implement JavaScript objects. The distinction is important because JavaScript maps can actually have anything for a key, whereas JavaScript objects can only have numbers or strings as keys. So in Berlin, because of that, because it takes advantage of that, you could have an array as a key, right? Just like in Ruby.
And can you have another function?
Yeah, absolutely. You could have a function. Say, for example, there's an equal function. Well, this might look weird. Let's say there's an inc function, for example, that increments an integer. And you could have an inc function. I don't know what this map would possibly signify, but just to showcase that you could have a function. You could have anything as a key or a value. Doesn't matter. And then there are sets, which the literal for that is you just put the things that you want in your set into the curlies.
No,
right
set is set similar to Python's set? I don't know if you...
I'm not a Python programmer. It's just a collection of unique values.
Unique values that are optimized to search for them without the the overhead of indexes and keys, right? Something like
Right.
that.
So if you want to check if a set contains a certain value, it's going to be constant runtime. Whereas if you want to check if an array contains it, or a linked list or something contains a certain value,
Okay.
that's linear. So those are the literals. Does that all make sense so far?
Yeah, this is great.
Oh, there's the comments. So comments start. I actually wonder if these. I haven't tried these in the console, I don't think. Yeah. So you just start a single line comment with a semicolon. So that's also borrowed from Clojure. There are no semicolons other than for comments. So you don't end your. Thank God you don't end your lines with a semicolon. That's not necessary.
Why not the typical forward slash?
I don't know what the motivation for using a semicolon as a comment indicator was in Clojure, but if I had to guess, I would say that, if you have an aversion to semicolons, the best place to put them is into comments, or to have them, to make them have only that meaning, because that means they themselves will never intrude on your program, because they themselves signify that this is not part of the program. So, yeah, if you want to demote, semicolons, I think it's a great way to do it.
Okay.
Let's see. Yeah, so like I said before, none of the Berlin core functions mutate anything. What does that mean? So, for example, let's say you want to. Let's say you have an array of 1, 2, 3, and you want to increment each value. Then what you would do is write something like this. Now, the implementation of map does not change this array. So if you have a reference to this array, that reference will stay intact. Nothing will change. It will simply return a new array that contains the result. And this is true of all functions in the core of the Berlin language. It never mutates. So you can always rest assured that whatever references you have to some data structure, they may be out of date, but they won't have changed from under you. And like I said, you can use mutation in Berlin, but you have to do so conscientiously. You have to kind of go out of your way to do it. And it's discouraged. And then after that, so there's really only two things in Berlin, other than the literals that I just showed you. There's special forms, and then there's functions. Special forms are things like if, def to declare variables, function declarations. The transpiler knows about these. These are things that live in the transpiler that when the transpiler recognizes them, does something special.
So I noticed there's no end to end your functions here.
Right. So the delimiters are just the parentheses. Right. Is that what you mean? There's no end keyword like in Ruby?
Yeah, still kind of shocking, I'm sure, to a lot of programmers. It also looks like it's indentation based or something here. Is that?
It's not.
Okay.
It's not. No. So let me show you. So if you run like something like the if special form, and even special forms look just like functions. So as a consumer, you don't really have to care that they're special in some sense. But you can almost, because if just looks like a function, there's no need to have a separate ternary operator, right? Because this reads just like a ternary operator, to me anyway. The ternary operator is not in the middle here, but otherwise, I think it works just the same. And so all you do in an if statement, in an if special form, is you put the condition first. I mean, surely your viewers will just kind of get this automatically, but and then you put the thing that you want to return if the conditional is truly, and then you want to return and otherwise you want to return this is the second thing. The third thing is the thing that you want to return if your condition is falsy. Now, of course, sometimes you want to actually do things not just return some value, right? Returning some value, that looks more like a ternary operator because of that. If you want to actually do something, then this is a more realistic example, and that's where you use these curly braces here. So I don't know if you can see this well.
Yes.
So basically what you're seeing here is different groupings. You say, okay, we're still just calling the if special form. Looks just like a function. It still just takes 3 arguments. The first thing is the conditional still, and then you pass in what's called a block. And these are very similar to JavaScript blocks, but in Berlin, they strictly only work in special forms and in functions. You can't just use them all over the place. And so what this will do is it will take this block and evaluate it step by step. Now, actually, this is the case if you run the simple special form, if special form as well. What the transpiler will do is it'll see, oh, there's a number 1, and we still want to treat this as a block, but it kind of surrounds it with curlies for you. And that happens a lot also with functions. You might think initially that you're going to use these curly braces a ton all over the place, but it's actually not true. I think in the entire core of the language, I use them maybe twice. But in any case, if you need to do multiple things successessively, you use these curlies.
Or you can, if you don't like the curlies and you want to make your code look more neat, you could, in the first line ternary here in this example, one could be a variable that points to a function, right? Could you do that?
Yes, but you would have to invoke that function here.
So you'd have to add curly braces.
No, you could just have your function invocation here.
Without the curly braces, because the transpiler actually go through and inject those curly braces for you. Right.
So let's say this is your if statement. That would work just the same. Now, if we're just a normal function, so let me back up. This is the same as writing, I think I put spaces in there. It's the same as writing this.
Okay.
Right, but because these are single line blocks, you don't have to put the curlies.
As less of those as possible, please.
Right. Yeah, they're not pretty, but like I said, as you'll see, I think as you write Berlin, you won't find yourself using them very much. In fact, they can be an indication that you're writing imperative style code, that you're mutating something or performing some side effects. Now, you can't always avoid that, but they definitely don't fit within the functional paradigm. So if you have a lot of these curly braces, that can be an indication that maybe you want to think about rewriting. Yep, you want to maybe do some refactoring there. Now, something else to note is that if we're just a regular function, not a special form, of course, it would just invoke foo immediately, right? Because foo, the result of foo needs to be passed to the if function. That is not the case because if is a special form. The transpiler knows not to generate JavaScript that immediately invokes this. It actually waits. It checks, is this true? If this were false, it wouldn't invoke the foo function. It would just return 2. Okay, then actually let me skip a bit to def and get back to functions later. So def is super simple. Also, the nomenclature borrowed from Clojure again. Basically, all it is declaring a variable. All that def is for. Something to note is def is only to be used for top-level variable declarations. So outside the scope of any function, that's when you want to use def. Or if at the very top you want to declare some constant that the rest of your code relies on, that's something you would use def for. And Berlin heavily discourages using def again to reassign a value or to override a variable, I should say. And in fact, in certain JavaScript environments, if I try to change the value of x to 2, that would throw an exception. I know that Node throws an exception for this, and I think in Chrome they just changed it. In Chrome you can actually do that now. So the reason this throws an exception is actually what you can see here is the output from the transpiler. So writing def x2 transpiles into this line of JavaScript. So just let x equals 2. And the same thing happened up here with x equals 1. And so Node, because this is running in Node right now, Node was complaining that we've already declared x, and so threw an exception. If you were to run the same thing in Chrome, I think it would just let you do it.
Interesting. Yeah, def sounds like a global variable of some sort.
It's not global. It's only going to be available in the file that you use it in. It's not going to be globally available in your entire program, say.
Okay.
But yeah, I would use the term top level to describe it. Yeah. Of course, that just kind of begs the question, because sometimes you do need to override a variable. So how would you do that? Well, so there's this other thing called let. And let is not used for top-level variable declarations. Let is used within functions. You could use this at a top level. Nothing would stop you from it, just like you could use def within a function. Nothing would stop you to do so, but that's not what it's for. So let, even though I'm not in a function right now, is basically the signature looks like this. You have some array that you put the variables in that you want to declare. So let's say x you want to set to 1 and y you want to set to 2. And then you want to do something with it. Let's say we just want to return x. All this would do. What let does allow you to do is reassign variables. Say at this step x is 1, and now at this next step we actually want to override it. And you can also use x in the next step here. So you could say first x is 1, and then we're going to increment it and assign that to the variable x again. And so then at this point x is equal to 2.
Nice.
Something to note also, which you may have noticed just now, is there are no explicit return statements in Berlin. So this is another simplification, also borrowed from Clojure, just like let. When you write a function, it's just the last statement is the thing that's going to be returned. The value that the last thing returns is the return value of the entire function.
Nice.
That is why this entire let block returned 2, because it returned x.
X is the last. Anything that's the last argument is the
exactly. Yep. And that continues in a deeply nested fashion. So then there are function declarations. Now, this is definitely where Berlin breaks, I think, in an interesting and useful way with many existing programming languages. Function declarations look a bit different. The signature looks different. So what I mean by that is you can see here, I think to someone who isn't familiar with Berlin syntax, this looks utterly foreign. This function AA, right? But recall from our example with the if special form, function fn is also a special form that returns a newly declared function. And this is the same as writing this.
Yes.
And maybe now it becomes a little more clear. Basically what the transpiler is going to do, it's going to realize, this is using fn, so I know what to do. I'm going to put the last thing, if it's a single statement, I'm going to surround it with curly braces because it's a block that's implied if we don't use any curlies. And that is why something like this makes sense. In any other language, you would read this and you would go, this is a function that takes 2 arguments and they're both called A. That doesn't make sense. But in Berlin, the last thing passed into the function declaration is actually the body of the function. It's not a parameter. So this function only takes 1 parameter called A. And then what it does is it executes a block that just immediately returns A. And so something like this, although it may initially look weird, I think is once you get used to it, it's actually just a neat way of declaring an identity function. It just takes A, returns A. That's all this function does.
But if you rename function to something else, your own function name, then that's different.
Well, fn, you can't really rename that. That's just the name of the special form.
Yes.
If you wanted to, there is already an identity function, but if you wanted to declare a function with that name, identity, this is what you would do. now you would have a variable called identity, and you would have assigned to that variable a function that takes A and immediately returns it. Now, if you call that with number 1, it's just immediately going to return the number 1.
Nice.
And something to note here, also in JavaScript, if you were to declare a function and then immediately invoke it, you would have to actually surround it with parentheses. In Berlin, that's not the case. You don't need to surround anything with parentheses. You should never have to do that. In fact, I think the transpiler wouldn't even know what to do with it. So something like this is perfectly valid code. It's basically shorthand of doing what I did here, where you skip the step of assigning it to a named variable. This is, I think, maybe a good illustration of how far you can go without using blocks. Because basically what this function does is it takes a parameter A, and then recall that this entire thing is the last statement that you pass to the special form fn. And so it's going to wrap all of it in a block. And so you can go as far as just invoking a function in that block. And what you will see later on is because you can just pass a let statement, in fact, you will probably do that frequently, you can pass a let block in here. And so you will almost never use blocks. You will almost never use curlies, but we'll probably get to that later. But here's an example of where you do need to use curly braces because you're doing 2 separate things that happen on the same level in terms of scoping. And like I said earlier, this can be an indication that you're doing something with side effects. Like here, you're logging something to the screen or to the console. Mm-hmm. And then you're returning the result of performing an addition on the 2 variables that are given. So those are functions. And this is the thing that you'll probably use 95, maybe 98% of the time in Berlin. Actually, hopefully only 95, because for the other 5%, and I do hope that this will find as many use cases as possible, there's a new feature that I'm not familiar with any other language having this feature. And this is based on an idea by also Brian Will, who I mentioned earlier in the context of object-oriented programming and its pitfalls. He mentioned in one of his videos, unfortunately I don't remember which one, it's on his channel somewhere, where he said, how cool would it be if there was a language that allowed you to declare a special kind of function which can strictly only operate on the arguments it is given. Because usually we have something like, let's say you declare, I think I've already declared the variable x, right? Let's say you declare a function that just returns x. This is obviously a contrived and very simplified example. You would do other stuff and then return x. But the point is, this is a function that takes no parameters and then just invokes a block and immediately returns x, right? Mm-hmm. Now, how come this function even has access to this? Well, because it closes over the scope outside of it, right? So this is a closure. And this, of course, we all know from JavaScript and in Ruby and Clojure, this all works. These function closures all work the same in these languages, and that's a very useful feature. What it does mean, unfortunately, is that as your code becomes more complex, and as your function has more and more dependencies on variables that were declared outside of it, things get messy. Excuse me. And in fact, it becomes much harder to reason about your programs, right? Because you don't know, maybe next time you run this function, x has changed. So then the behavior of your function changes also. Even though whoever changed x may not have intended for this function to change. They may not even have known that this function exists and depends on x. So you have some bleeding going on there. X kind of bleeds into this function, and this might lead to unintended side effects. And the solution to this problem is to have what I call strict functions. And these are declared just like regular functions, with the only exception that they end with a bang. And the way this works is the identity function, for example, is probably the simplest example of a strict function, because all it operates on is the argument that it was given. it doesn't operate on X. In fact, if I try to return X here, right, normally if this were a regular function, this would work. I could declare a function that takes some parameter A, doesn't do anything with it, so this is obviously a contrived example, but then just returns the parameter X, and this parameter X, or not a parameter, it just returns X, and this X was bled in from outside. So depending on the value of X, the return value of this function changes. So that's very messy, but it would work. I could invoke that function. With a strict function, I tried to return X here. The transpiler won't even let you do it. It never even makes it to JavaScript. And so what the transpiler does is, hey, I can't access symbol X in the strict function. So it's complaining about this guy. And it says you have to pass in X as an argument. Or you have to declare it inside the function somewhere using a let block. Otherwise, it's not going to work.
Nice. And if you wanted to, you could, if you wanted to reuse a variable outside of this function, that's how you would put that variable inside this function with a bang, is that you would declare it.
If you wanted to use it outside the function? What do you mean?
So let's say you did want to use A, and A existed outside of this function here.
Yeah.
You could pass in that variable in the first argument here with the bang.
Right. So the strict function isn't going to close over any of the variables on the outside. So you could simply use A, and let's say this is, again, just the identity function. It just takes A and returns A. Whether or not you have a variable outside that's called A, it doesn't matter at all. The strict function is not going to care. You simply pass it you pass in a parameter a value that then gets bound to A, and then it immediately returns this in this case.
But what if you wanted to use a variable A?
Oh, sure, you could do that. So let's say, we're declaring a strict function, and previously you're saying we've declared A?
Yes.
Like that. And now what do we want to do?
We want to use that in the strict function.
Well, if you're trying to reference it in here, it's not going to work. The transpiler is going to throw an exception. So all you can do is say this function takes some parameter B and then does something with it. And then later on, when you invoke this function, you can invoke it with A. That's how you get to use the value of A inside this function. You just have to pass it explicitly. There's no implicit bleeding of variables into this function.
You answered my question. Yeah, this was, I thought maybe you could reuse variables inside strict functions, but now I know that if you want to reuse those, you use them to execute outside of the strict function right there.
That's right, yeah.
Okay, cool.
Yep. Okay, yeah, so that's the story of strict functions. And so the hope there is that it just makes it easier to reason about your program. I would encourage people to use strict functions as often as possible whenever they can. And in fact, I put an example up here. Let's say you're writing a calculator app. So you create a UI with the buttons and everything. So you have your plus button, minus, and times and divided buttons. You could have a separate function for all of them, or you could have a math function that is itself a strict function, signified by the fact that it ends in a bang. So I suggest that as a convention. If you're going to declare a strict function, have its name end in a bang, so that the consumers of this function know that it's strict. And then what the strict function takes is 3 arguments, some operation that you want to perform. This is going to be a function such as plus or minus. Again, these are functions in Berlin. They're not operators. And then 2 additional parameters that you want to perform this operation on. And so now you can see here that this function, really, it doesn't do anything other than invoking that function with these arguments. There's nothing else going on. So this is about as simple as it can get. It might seem trivially simple, it might seem contrived, but it's not. This is the kind of abstraction that I think you would want in your program, because it makes it easier for you as the creator of this function to reason about it. You know that whenever you look at this function, nothing bleeds into it, nothing bleeds out of it. All that's happening is within the confines of this function. And also for you as the consumer of the function, you see this bang, and you know that you can confidently make changes elsewhere. It's not going to affect the behavior of this function or the return value.
Nice.
So basically, what strict functions do is they increase referential transparency, by which I mean, in this case, for example, if you invoked, say, the math function with times function and 2 and 3, this would evaluate to 6, because 2 times 3 is 6. Referential transparency is when you can simply cut this out and replace it with the value it returns. That's what strict functions, they don't guarantee it, but they increase the possibility that the function that's strict is referentially transparent. I say they don't guarantee it because the function might still cause side effects, and side effects might, change some state elsewhere, and that operation might not be idempotent. So when you perform the side effect again, that leads to a different change maybe. So referential transparency is not guaranteed here, and you could imagine that as a convention on a team, that if you're going to declare a strict function, that you're not going to have to perform any side effects.
Yeah.
And so at that point, you would just know that strict functions are always also pure. So those are strict functions. And that's basically it to the language. Everything else is just the core. Once you have these 5 special forms, you can do everything that you need to do.
Man, it's like Thanos and his 5 stones to rule the universe.
Oh, yeah. Yeah.
Code bases that are profiting, they usually, from my experience, have some kind of test suite behind them. Does Berlin have anything, or are you working on it, or?
Well, so the core of Berlin is itself well covered by tests. Every function is covered by unit tests. But I think what you're asking is if you want to write code,
yeah,
right?
As me as a coder, developer.
Well, so again, because Berlin transpiles into JavaScript, nothing is stopping you from using a testing library that already exists in JavaScript, like say,
okay,
and just use it to write unit tests, for example. Yeah, you could absolutely do that.
Okay. Another common function that's essential is the infamous XHR request or AJAX call.
Sure.
Do you have any kind of helper for that?
Well, you don't need a helper for it. All you need to do is basically just call the function like you would in JavaScript, with the assumption that you're going to run this in the browser, say. Okay. So I forget the exact syntax in. Maybe you can help me out. Is there a send XHR request or something? Is that what
jQuery, it's just $get and post.
Oh, here you go. Right. So if you wanted to, if you're writing Berlin and you want to run the produced JavaScript code in the browser, and you want to make an asynchronous web request, you can absolutely do so. And it would be very simple, in fact, because this is a global object in the browser, and it has a send method. And so this actually brings us to the topic of JavaScript interop. If you need to interoperate with any of the natively available classes and objects, such as the XML HTTP request class or prototype, I guess, you could do so. And what you would do to signify the interop, this is also borrowed by Clojure syntax, is you would call send on this object here, and then with whatever body. And so you would send hello. I'm not sure where they specify the... Oh, you have to instantiate it first. I see. Man, I haven't written a manual AJAX request in a long time. Yeah, okay. Yeah, so if you wanted to, just as an example, if you wanted something like this written in Berlin code, this is actually an interesting exercise because what's happening here is you're using you're instantiating a constructor, right? Mm-hmm. But there are no prototypes or classes in Berlin. So how would you even do that? Well, through JavaScript interop, you absolutely can do this. There's no way of declaring a new constructor in Berlin, but you can definitely interface with existing constructors. So if you wanted to write something like this, I'm just going to copy this over into Berlin here. So line by line, I'm going to put the translation right underneath. Should I put it right underneath? I'm going to put it next to it. You would say def xhr is XML HTTP request, and then you put a dot behind it and then invoke it. This dot at the end is how the transpiler knows that you're instantiating a constructor. So that will result in this new keyword. So now you have a variable called xhr. That's an instance of the XML HTTP request constructor. And then what you would do is call open on this xhr object with get and server and true. Then what you would do here is you would assign this onload function. And Berlin, you can see this in the docs at the very bottom when it comes to JavaScript interop. If you really do need to mutate, such as in this case, where you do need to mutate the XHR object, you want to assign this function to this property. There's this set property special form in Berlin. So you would call set property on XHR on load, and then just the function that you want to, whatever you're doing in here. Presumably inside a block, maybe. And then this line is easy. You just call send on XHR and invoke it with null.
Cool.
So this is how you would send an AJAX request in Berlin through a browser.
Cool. That was, I think, a very important exercise there to demonstrate merging in the real JavaScript world here.
Right on. Yep.
With Berlin here.
When JavaScript, when ECMAScript 2020 or whatever they're going to call it comes out, then any new features that's going to have is going to those are automatically going to be available through JavaScript interop in Berlin.
Very cool. All right. So besides these 5 major functions, are there other helpers? Things like helping you sort through an array?
Yeah, so the core comes with, I don't know how many, a decent number of functions that are kind of library functions that help you write your everyday code. So you can find those in the docs here. That's basically the bulk of the documentation is just about those functions. So
nice.
Anything from checking for types to, math. This, for example, how you invoke the plus function.
Because, just a reminder, there are no operators. That's still
right.
a big difference here. Everything's a function.
Right. I mean, this should be fairly clear what kind of an influence Lisps have had on Berlin is because that is the same in Lisps, such as Clojure. The same with the function signature here is that you can pass as many arguments as you want to the plus function. Or if you invoke the plus function without any arguments, it'll just return. These are all things that are borrowed from Clojure specifically. And so, there are neat things you could do because of the simplicity of these functions. When you combine them in good ways, you can get very simple but powerful behaviors in your programs. For example, let's say you wanted, for whatever reason, you wanted to have a custom implementation of multiplication. And let's say you wanted to multiply, it's just always two numbers, right? There might be different ways you could do that, but you could say, okay, we're going to declare an asterisk, a function with the name asterisk, or you could call it multiply, whatever you want. There already is one called with the name asterisk. And so this is a function. Let's say it takes A and B. And then, so this is what I do when the block is non-trivial. I put it in its extra separate line. And then what you could do is repeat B 8 times. And like if you wanted to implement multiplication in terms of repeated addition, say. And then you could reduce plus function over that. So what's this going to do? So if we call repeat, say on 3 and 4, that'll give you an array that contains the number 4 3 times. And now all we need to do is add them all up. And one way to do that is to call reduce plus, because again, remember, plus is just a function. Reduce takes a function and some collection that you want to reduce over. There you have it. 3 times 4 is 12. Now, something else to note about Berlin syntax is that this kind of reads out of order. You're calling reduce using the plus function on the result of this repetition. It'd be easier if you could read it the other way around. First, you're repeating B 8 times, and then you're reducing plus over it. Berlin does have something for that. So you could write the same thing using this function. It's by the exact same name. In Clojure, it's called a thread last operator. Works a little bit different in Berlin, though. The way you would do it here is you would say, okay, we're going to use B, then we're going to repeat it 8 times, and then we're going to call reduce on it with the plus function. So now what you can do is you can just read it in order, which hopefully makes it, easier as a consumer, or actually as the maintainer of this function, to reason about it.
So you have options there.
Yep, you definitely have options.
In terms of readability. But I'm seeing the parentheses in the way that you don't have to use this operator here. That coders will see the parentheses and it'll guide them. Even if it's out of order, the parentheses help guide the order.
For sure, yeah. Yep. Something that may throw people off initially is this collection of parentheses at the end here. This is very common in Lisp programs, and it's also usually one of the first concerns raised about Lisp programs, even though Berlin itself is not a Lisp, but this was definitely an influence from Lisp, is that you have all these parentheses all over the place. I can assure whoever's watching that don't worry about it. You won't even see these anymore. That's
an indicator of closing your previous parentheses, right? It's just how you close.
Right. All you're doing here is closing the previous parentheses, exactly.
But Lisp keeps them all in one line, whereas people rather have them on separate lines, or?
Right, so that's what I was going to say. Is like you could do that here. You could do something like this, okay. But yeah, you just end up with a lot of extra lines. And like I said, over time, you won't even notice these anymore. And then you can have helper tools like, in your text editor, you can have rainbow parentheses and whatnot, and you have these highlights anyway. So yeah, I would, the recommended Berlin syntax, although it's not enforced because there's no such thing as transpilation based on indentation or anything like that. I would just put them all at the end in the same line.
Yeah, it definitely looks nicer. Cool. Yeah, I guess let's see an exercise.
Sure. So I guess one thing we could implement is something simple like a factorial function. So if you wanted to have a factorial function, you could say it takes a number n, And then what it does is say if n is less than 2, it just returns 1. And in all other cases, it returns the result of multiplying n with factorial of decrement of n. Work. So in other words, it takes a number n. If n is less than 2, it just returns 1. Otherwise, it multiplies n with whatever factorials returns for n minus 1. And that's what this would look like.
This is a recursive thing going on here.
That's right. Berlin employs recursion a lot. In fact, there are no loops in Berlin. So yeah, you're going to want to use recursion. And something that should be included in Berlin, should be added to the Berlin language, I think, in the future, is making it so that you can do tail recursion without consuming the stack. I think otherwise, this isn't an example of tail recursion here, but otherwise I think it's not quite fair not to have loops unless you make that available. But yeah, so what you're seeing here is this thing that's going on where technically all of this is a parameter that's being passed to the function, right? But it's a block. So Berlin is going to implicitly surround all of this with curlies. So all this function takes is a parameter n, and then because this looks like 3 lines, right? I mean, it is 3 lines, but everything that happens here happens within the if statement. And so therefore, as far as Berlin is concerned, this is all just one thing. There's nothing else happening on the same level as if. You would only really have to use curlies if you wanted to, for some reason, return the number 2 at the very end, or do something else here at the same level of the if statement. Then you would need curlies. Otherwise, you don't need them. Yeah, and that is why I said earlier that you probably won't use curly braces that much. For blocks, anyway. For sets and map literals, yes, but not for blocks.
Okay. Well, how about something similar to a case statement here in this if? What about other conditions that you may want to add?
So currently there's no switch operator or anything like that in Berlin. I have thought about adding something like that to the transpiler. That will then spit out a switch statement in JavaScript. But for now, you would just do nested.
Okay. Are there rescue blocks or a way to escape infinite loops? You just have to depend on make sure that your if condition actually works. Or
yeah, so if your function just keeps recurring, eventually it's going to blow up the stack and you're going to get an error message at runtime. Yeah, you just want to make sure that your return condition is eventually reached. But yeah, good point on the question of there is a throw special form in Berlin, or it might be a function, I forget. I think you raise a good point. I think I still need to implement a rescue.
all right. What does the transpiling look like?
Right, so let's say we wanted to transpile. I'm going to remove, let's see here. I'm going to remove much of this because I don't think we'll really need it. So technically, because I'm including the Berlin core here, these functions will need to be preceded by b dot. In the console, you don't need to do that.
What's that dot do?
Same as in JavaScript. It's just accessing a property on an object.
Okay.
You really only use the dots for JavaScript interop.
Okay.
So yeah, if I wanted to transpile this file, note that this is a Berlin file, .berlin, and I've transpiled this before, but let's say we delete that, and let's say there's no There's no JavaScript file yet, right? We can't run Berlin, actually. Like I said, it's a transpiled language. We can only run the JavaScript that results from the Berlin file. So what we have to do is transpile it. And what you do there, I'm in that directory right now. So you see here, there's my index.berlin. And what you do then is you run the Berlin command. And as you may have seen earlier, if you run it without any parameters, you just get the REPL. But if you run it with an input file and an output file, and that tells it, take this input file, transpile it, and put the result into this file. If this file doesn't exist yet, it'll create it for you. So if you look at on the left here, once I hit this, now it's created this index.js file. And this is what this results in. So if I want to run this now, I can, although actually this won't do much. So let's add something. Let's log. There's a log function on the core. Let's log factorial of 4. Save it. Now, right now, I have to manually transpile it every time I make a change, but that's not a problem. You could easily imagine, a tool that listens to, just like in TypeScript and CoffeeScript, presumably they do that too, where it listens for file changes and does it for you every time you change the file. I'm doing it manually right now, so I'm going to run that command again. I need to see that just added this line here. And so now we can, so this is the code that's eventually going to run. You're not actually ever going to touch that code. You always just touch the Berlin code. Also, this code looks ugly. This is not meant for human consumption.
But it looks great for memory, though, because it looks like it's already truncated.
It's a little bit truncated. There are some superfluous parentheses here and there, but it was definitely easier to build the transpiler that way. So there might be some very, very slight overhead here and there. But yeah, in terms of readability, it's definitely not meant for human consumption, or it's not optimized for human readability. This is just what the transpiler spits out. And you can see here, though, all this stuff, like you can infer some things, or not infer, but you can get some of the clues that tell you how the transpiler might work. For example, you see here return statements. The transpiler just knows when to put them, even though we don't have any explicit return statements here. It puts semicolons, right? You can see here that it uses ternary operators whenever you use an if statement in Berlin. You can see here that it has these things with these underscores and these capitalized names. That's from Clojure script. That's how they handled these special characters, for example, like this one. Right? Normally, these are operators, so we can't just translate them one-to-one into JavaScript, because JavaScript would think that this is an operator, whereas in reality, it's a function name. So this function name in Berlin is called the less than sign, but in JavaScript, this transpiles to this name.
Okay.
So yeah, and so now if we wanted to run it, let's hope it works.
This is basically how you learn Berlin, what your code actually does. Or one of the major ways.
Yeah, I mean, if you want to learn about the transpiler, I definitely recommend you just check out the code is all on GitHub, so it's all public. You can just read the transpiler there. But yeah, if you want to inspect the code, and let's say you're having an issue at runtime, and there's nothing telling you, you're looking at your Berlin code, and there doesn't seem to be anything that tells you what the problem is, it might be a good idea to check the result of the transpilation in the JavaScript file. For sure. But let's try to run this. So you would run this in JavaScript, right? So you just call node index.js. And there you go. The factorial of 4 is 24. Yeah.
So for the moment, when you're coding, to see the actual result, you will have to run the transpile line.
Yeah, so currently, if I make another change to this Berlin file, say I also want to log the number 10 for whatever reason, it's not going to include this yet. See, it's not here yet.
Yeah.
I have to run the transpilation first. Now it's here. But again, once you properly set up a pipeline for this,
yes,
you would just have a listener for file changes that runs the transpiler every time the file changes, so that you don't have to worry about it. This would be especially handy in say a front-end project where you have automatically reloading code.
No, this will definitely have to be implemented. It will eventually. Hopefully somebody can help.
Yeah, I'm definitely looking for contributors. If anyone's interested, I'd be more than happy to collaborate.
Cool. Yeah, we're at the forefront here of a brand new thing here, so this is great.
Yeah, that's right.
All right. Well, Dennis, thank you so much. This is so exciting, man, to not just the simplicity of the syntax, but of concepts. Your everyday things that coders do have been simplified also.
Yeah. No, you're welcome. It was a lot of fun talking about it.
Yes. What's the best way that others can reach you if maybe they want to help?
Sure. Well, you can. So first of all, you can find the source code on GitHub. The URL is this one here: github.com/dchacker/berlin-lang.
Okay.
So if you want to make any contributions, you can just do so right there. If you want to reach out to me personally, you can just send me an email, dennis.hackathol@gmail.com. It's probably the easiest way. Or you can follow me on Twitter too. I'm DC Hackathol on Twitter, I think, is my user handle.
All right. Cool. The beginnings, which are just what you're doing so far with the different concepts of simplifying things, all are important bedrocks to what's to come.
For sure.
It looks like I saw that list of available functions in your core library. Mm-hmm. It seemed like there's quite a few there already.
Yeah, and actually that reminds me, it might be helpful to show people who are watching what the core looks like, because it gives you an impression of what writing Berlin code, what the syntax looks like. So this is the core of the language, and you can see there are very few, like I said, very few curly braces. I almost never use them.
For the coloring in your IDE,
mm-hmm.
what do you start your project as so that your IDE has a sense to color it? And do you select it as a JavaScript project or?
Yeah, so I did generate a separate, I forget what Sublime calls it, like a separate language, template for the syntax highlighting for this, and it's just called Berlin. I haven't made that available, but it's basically just a subset. It's either equivalent to or a subset of the Clojure one, I think.
Okay. So people should try to select a Clojure for now.
I would recommend that, or JavaScript works too.
Okay.
Either one. Maybe I use JavaScript actually. I forget.
Try both.
Yeah, try both. But that would be super cool if anyone wants to collaborate. This is definitely an outstanding thing, an open problem, is building a proper syntax highlighting tool for Berlin.
It looks good so far. It looks like it's aware of where your parentheses start and end. So
yeah, there is that. Although it gets a little confused because, as you can see here, because this has a minus in it, it thinks that this is an operation of some sort, whereas it's really just a name, so it calls it differently. Those are the kinds of things that ideally it would. It's not highlighting if statements, for example. It'd be cool if like special forms were blue or something, stuff like that. None of that's rocket science. So hopefully soon we'll have proper syntax highlighting for Berlin.
That's enough to get anybody started. I'm pretty confident that if I'm going to contribute, start tinkering, that what I've experienced so far in this session, I'm good to go. So, yeah, I look forward to it, man. The world needs this. People are hurting from all of that front end abuse right now since 2015.
Right.
Things took a turn with JavaScript.
Right. I would be thrilled if a useful front-end framework can be built on top of Berlin. I think that would be very promising.
All right, Dennis. Well, thanks, man. Okay.
Yeah, you're welcome.
Okay. Talk to you soon.